Hello everyone! Welcome to Learn Spring Boot with Bingyang. In this video, we're going to explore a powerful feature of Spring Data JPA. Spring Data JPA specifications for constructing dynamic database queries so that users can narrow down their search results quickly. But before we dive in, let's briefly review the user stories that we have implemented so far. In the current Hogwarts Artifacts Online project, a user can find all magical artifacts and find an artifact by ID. In the last video, we enhanced the find all artifacts with paging and sorting. Now the users propose a new requirement. The application should allow users to utilize search criteria to find exactly the artifacts of their interest. This new requirement will provide a better search experience. As you can see, I have already added this new requirement to our user story document. As an anonymous user, I want to find artifacts by ID, name, description, and owner's name so that I can efficiently discover artifacts that I'm interested in. Recall that an artifact has 4 fields: ID, name, description, and owner. The link to this mind map is available in the description of this video. To help you better understand this requirement, I'd like to show you a simple HTML page about this user story. According to this user interface, a user can search artifacts by ID, name, description, and owner's name. All search criteria are optional. For ID and owner's name, they need to be an exact match. For name and description, they can be partial match. As a matter of fact, this find something by search criteria, or search with filters, or faceted search is very common in web applications. Other examples include in a recipe management application, a user wants to find recipes by ingredient, cuisine type, and cooking time. Or in a music app, a user wants to find songs and albums by genre, artist, and release year. This user story allows users to utilize search criteria to quickly narrow down the search results. Although useful, this user story involves many possible queries to the database. Next, let's follow the API-first approach and define a new API endpoint for this user story. Let's go to SwaggerHub. I have added a new endpoint /artifacts/search to our Swagger API document and upgraded the document version to 3.0.0. The link to this API document is available in the description of this video. This API endpoint returns a page of artifacts that match the provided search criteria. The 3 request parameters are for pagination and sorting. I explained them in the last video. Besides the 3 URL parameters, the front end needs to send a request body to the backend. Here are some examples of the request body. Recall the user interface I showed you before. In the first example, a user is looking for artifacts with a description that contains the word Hogwarts. In the second example, a user is looking for artifacts with a name that contains sword and a description that contains Hogwarts. This is a more restrictive search criteria and will yield fewer artifacts than the first example. In the third example, a user is looking for artifacts with an ID equal to this, a name that contains sword, and a description that contains Hogwarts. Apparently, there are more combinations of the search criteria that I didn't show here. Let's go back to description only. Based on this search criteria, here is the response from the Spring Boot. There are 2 artifacts that match this search criteria. I'm sure you already noticed that. Even though this is only one API endpoint, it involves many possible queries to the database based on user input. How do we implement those queries? Well, one approach is to hardcode a query for each user input. Let's go to the slides. For example, one user input is that the user only provides the artifact ID. Well, that's easy. We have done that before using findById. Since findById comes with JPA repository, it is built in. Another possible user input is that user only provides an artifact name. So we need to find artifacts by name. Recall that Spring Data JPA simplifies data access operations by using something called query methods. So we can add a method signature to the artifact repository interface, like this. The query method name reflects the criteria of the query directly in the name of the method. If you know SQL, Spring Data JPA will translate this method name to this SQL. The third possible scenario is that a user wants to find an artifact by a snippet in the description of the artifact. That's easy. We can add another query method to the repository interface, like this. So far, so good. Well, things get a bit complicated when we decide to combine the search criteria. The user may want to find artifacts by name and description. Okay, let's hardcode a method signature again. What if the user wants to find by ID, name, and description? Here is another query method. Do you see the problem? The problem with query methods is that we can only cover a few search scenarios. The number of query methods increases exponentially as the search criteria increase. With only 4 search criteria or search parameters, we need to hardcode 16 query methods in the repository interface. What about 5 search criteria? There will be 32 possible query combinations. This considers all the ways each criterion can either be included or not included in a query. Simple math. There is another problem with this approach. The query method name's length can grow considerably with long field names and many criteria. So, understanding the purpose of such an extended query could require a significant amount of time. In other words, the readability of the code decreases. Here is an example I found online. It is not relevant to our Hogwarts application. This method demonstrates a query for a user entity based on a case-insensitive match for both first name and last name, an email address containing a specific substring, and a registration date falling within a specified range. It also specifies that the results should be ordered by last name in ascending order. As you can see, the method name is quite long and somewhat difficult to parse at first glance due to the complexity of the query conditions it represents. Then, how to efficiently handle all possible criterion and return a consolidated search result? An elegant approach is constructing dynamic query using Spring Data JPA specification. The idea is simple. We start by defining each search criterion as a specification. So the first specification is has ID. Then the second one is contains name. Then contains description. And finally has owner name. Specification is a concept from DDD, or domain-driven design. It allows for the construction of business rules that can be chained or combined using logical operators like and, or, not. In the context of Spring Data JPA, specifications are used to encapsulate the search criteria into reusable specifications. Now we have those building blocks, or atomic specifications. We can start to combine them into complex queries based on the user input. For example, if the user only provides a fragment of the description, the dynamic query will only use the third specification. Next example. If the user provides name and description, the dynamic query will use the second and the third specification, and combine them into one specification using logical operator AND. So this AND operator returns a new, more complex specification. Next example. If the user provides ID, name, and description, the dynamic query will use the first, second, and the third specification, and combine them into one complex specification using the logical operator AND. So the key concept here is that we can construct a query programmatically at a runtime based on the user input, hence the name dynamic query. This makes the code cleaner, maintainable, and scalable. With that, let's go to IntelliJ and implement dynamic queries with Spring Data JPA specifications. Let's create a Git branch first. Git switch. First, let's create a class called ArtifactSpecs to serve as a container for specifications about artifacts. In this class, we will define 4 static methods, and each of them returns a specification object. Let's create the first specification object for the first search criterion, has ID. Public, static. The return type is specification, so make sure you import it from the correct package. And then the generics type will be artifact, has ID, and it takes in a string, the provided ID from the front end. This static method is supposed to return an instance of the specification. So return new specification. Okay. It turns out that specification is a functional interface defined as follows. So let's click inside. There are many static methods, not, where, and, or. So when creating an instance of a specification, we must provide the implementation of this toPredicate abstract method. And there are 3 formal parameters: root, query, and criteria builder. So let's go back to ArtifactSpecs. Let me explain the 3 formal parameters of this method. Root. If you are familiar with SQL, think of the root as the from clause in an SQL statement. The root always references the persisted entity, in this case, the artifact. And we can use root.get, here, for example, ID, to get the ID attribute of artifact. Query is used for ordering results, or specifying that we want distinct results, or specifying the grouping by attributes. The third parameter is criteria builder. It is very important. We use the criteria builder to construct search criteria. You can think of it as the where clause in an SQL statement. Next, let's implement this hasId method. The goal is to query the artifact table and find artifacts with ID equal to the provided ID. And here is the syntax. Gonna cut this. Criteria builder dot. As you can see, there are many useful methods in the criteria builder. For example, equal, upper, like, ASC, between, greater than or equal to, less than or equal to, and so on. And here we're going to use equal. This equal takes two arguments. The first one is the column name of a table if you're using SQL language. Or in our case, it is the attribute name of artifact. So we can paste it here, root.getID. So here we're getting the attribute ID from artifact and compare it with the provided ID. So this expression returns a predicate. Let me change the name to hasId and return it. Or let's simply just merge these two lines into one line. Spring Data JPA will translate this specification to this SQL statement. Select asterisk from artifact, where ID is equal to whatever is in the provided ID. This code is a little verbose. Since this is a functional interface, let's convert it to a lambda expression. There you go. Next, let's work on the second specification, contains name. So let me copy this and do a paste. Change the name to contains name. Provided name. Now this time we cannot use equal because equal is exact match. We want partial match. So let's use another method in criteria builder called like. There are two wildcards often used in conjunction with the like method. The %sign represents 0, 1, or multiple characters. The underscore sign represents one single character. Now in this case, we're going to put %sign before and after the provided name. This will make Spring Data JPA return artifacts with a name containing the provided name. Just make sure you add %sign both before and after the provided name. By default, this search is case sensitive. In this case, I want to make sure the search is case insensitive. In other words, ignoring cases. So here is how we can do that. Let's first convert root.getName to lowercase by using criteria builder dot lower, and then convert the provided name to lowercase. So that's a string dot to lowercase. There we go. The third specification is similar. It is called contains description. Okay. This specification returns artifacts with a description containing the provided description. Okay, let's work on the last one. Public static has owner name. Return root query criteria builder dot, and this one should be an exact match. So we're going to use equal, and let's also ignore case. Criteria builder dot lower root dot get. Now this is interesting. We're going to get owner first. Recall that owner is actually an object. So we can keep using dot get name. Recall that owner is actually a wizard object. We're getting the name of this wizard. And then compare it with the provided name dot to lowercase. Okay, we're done. Okay. And in the future, we may add more specification definitions in this class. As you can see, this approach makes our application more scalable. Next, let's modify our artifact repository interface. To support Spring Data JPA specifications, we need to make our artifact repository interface extend one more interface, the JPA specification executor. This one. If I click inside, this interface provides a very powerful method called findAll based on the provided specification. Recall that we can use logical operators like AND or NOT to create new specifications based on the 4 specifications we created in ArtifactSpecs. So we use logical operators to combine them and pass the final specification to this one, findAll based on this specification. Next, let's implement the controller method and then the service method. And the service method will call this findAll method defined in the JPA specification executor. Actually, we're going to make it call this findAll version to also consider pagination and sorting. Okay. Based on the API documentation, let's define a new controller method called findArtifactsByCriteria. And this is a post mapping. And here is the URL. The user will provide some search criteria in the request body. But the problem is that some search criteria may not be there, or in other words, may be absent. For example, the user may only provide a description. So how does the controller method receive those values? Here is what we can do. I will use a map object as the formal parameter of this controller method. So here, let me define a map. The key is string, the value is also string, and the name of this map is search criteria. And let me annotate this map object with request body. Okay. Recall the purpose of @request body. It gets the HTTP request body and then deserializes the request body into a Java object, in this case, a map object. Take a look at this picture. Search criteria is a map where keys represent the criteria fields and the values represent their respective values to search for. This is done automatically by Spring Web MVC. We call this behavior data binding. It binds the HTTP request body to this search criteria map object in the controller method. How convenient. Let's also enable pagination. The pageable parameter is used for pagination and sorting. Okay, next, let's implement this controller method. So we're going to use this method from artifact service, even though it doesn't exist. This dot artifact service dot find by criteria and pass the two parameters to it, search criteria and pageable. I know it doesn't exist. And it's supposed to return a page of artifacts. Let's call this artifact page. And then we're going to convert a page of artifacts to a page of artifact DTOs. Artifact to artifact DTO converter. And let's use this method reference, convert. And here we're going to return it. New result, true. Status code is success. And the message is search success. And the payload is artifact DTO page. Okay. Okay, we're done here. So here in summary, line 92 calls a service method findByCriteria with the search criteria map and pagination information. It returns a page of artifacts. Line 93 maps each artifact entity in the artifact page to its DTO, or data transfer object, using a converter function in artifact to artifact DTO converter. The mapping to DTOs is a common practice to encapsulate and transfer only the necessary data to the client side. Finally, line 94 returns a result object, which is our custom response wrapper. Okay, next, let's implement the findByCriteria in artifact service. This method is responsible for constructing the dynamic query by combining the atomic specifications defined in the ArtifactSpecs class. So let's start with a base specification that is effectively null. Specification, artifact, spec, Specification.where, null. This spec object serves as a flexible starting point for dynamically building up our query. Since in Spring Data JPA, combining null specifications using AND or OR method with other specification simply returns the non-null specification. So this is a good starting point for the dynamic query. Next, we should decide whether or not to include the 4 atomic specifications by checking the presence or absence of search criteria provided from the front end. Recall that this search criteria may have 1 key value pair or 2, or 3, or 4, or none, right? And here is the logic to determine which atomic specification to include or not. If, and here we're going to use a utility class, string utils dot has length, search criteria dot, this is a map, so we can dot get the key name, let's say ID. If the value associated with the key ID exists in this map, we should combine the has ID atomic specification with the base specification spec. And here is the syntax. Spec is equal to spec.and ArtifactSpecs.hasID. And here we're going to pass the provided ID, search criteria dot get ID. This is because the provided ID does exist in the search criteria map. Okay, now for the second atomic specification. If string utils dot has length, search criteria dot get name. If the value associated with the key name exists in this map, we should update the dynamic query spec with contains name. Spec dot and ArtifactSpecs dot contains name. Then we're going to pass search criteria dot get name. Then I keep going. If string utils dot has length, description, and the last one, owner name, okay. All right, finally, we should return this dot artifact repository. Now recall that since our artifact repository extends the JPA specification executor, now we can access the find all, this one. We're going to pass this spec. Now this is the final specification, and also we're going to pass the pageable to it. Okay, a quick summary here. Line 104, we created a base specification to start with. Then from line 106 to line 120, we have several conditional checks. We need to check each key in the search criteria map to see if it is associated with a non-empty value. For each non-empty value, it constructs a new specification by chaining conditions using the AND method. String utils.hasLength checks if a given string has text, effectively ignoring null and empty strings. The idea here is to dynamically build our query based on the search criteria provided at runtime. If a specific search criteria is absent, we can effectively ignore it in our query construction. In the end, line 122 executes the query according to the specification and pagination settings, and it returns the result as a page of artifacts that match the provided search criteria. Okay, next, we need to modify the security configuration here to allow public access to this endpoint. Post this dot base URL plus artifact search dot permit all. Okay. So make sure you add this line in the security configuration class. Okay. Now it's testing time. Let's test in Postman. First, let me start my application. Okay. Now let's go to Postman and test this findArtifactsByCriteria endpoint. So this is a post request, and that's the correct URL. Next, let's add a request body to this post request. So for example, let's only include one search criterion. Description, Hogwarts, and click send. It is good. The backend returns two artifacts with descriptions containing the string Hogwarts. Since we didn't pass paging and sorting parameters, the default ones will be 0, 20, and unsorted. Let's test more. For example, name is equal to sort. Now this time we only have the second one, the sword of Gryffindor. That's great. Now let's go back to IntelliJ and take a look at the SQL generated by Hibernate in the console. Let's only look at the last test, find artifacts by name and description. Let me copy this SQL and paste it into a text editor. So this is the SQL statement generated by Hibernate for this API call. Okay, let's go back to IntelliJ and write two integration tests for the controller method. Before we wrap up, let's write some integration tests for this findArtifactsByCriteria controller method. Add test void test find artifacts by description. Given when and then. So in given, let's prepare the search criteria map. Map string search criteria new hash map. search criteria dot put description Hogwarts. And then we're going to serialize this map to JSON using this dot object mapper dot write value as string. Here, let's throw the exception. Okay. All right. So here, let's use mock MVC to perform a mock post request. So let me copy the code from here. Let me change the URL to search. And here should be post. Here, let's change this to content type. We don't need a header. Dot. Content is this JSON object right here. Dot accept application JSON. All right, so here in this test, let's also mock the pagination parameters. So here, let me create a multi-value map. String request params new linked multi-value map. And let's add in 3 URL parameters. Page 0, request param.add, size is, for example, 2 items per page. Request params.add sort, just sort by name in ascending order. Okay, now let me copy this one and add it to this mock request here. Dot params dot accept. Okay, there we go. So mock MVC perform post request to this URL. The content type is JSON, and the content is JSON, which is description equal to Hogwarts, with 3 URL parameters and accept JSON as the response. Okay. Now we know that this one is supposed to return 2 items. There are 2 artifacts with description containing Hogwarts. And this one should be search success. So let's run it. Okay, good, it passed. Next, let me do one more. Copy this and paste it here. Find artifacts by name and description. Here, besides description, let's also add a name. Sort. And let's make this one first. Okay, everything else is the same. This time, it only returns 1 result. Okay, so let's run it. Okay, passed. All right. Next, let me start all test cases to make sure that we're not breaking anything. Okay, all passed. Next, let me commit and push the changes to GitHub and deploy the application to production. Git add git commit implement find artifacts by search criteria with Spring Data JPA specifications. Git push Then let's go to GitHub and create a pull request. Compare and pull request. Create pull request.
$2,000 years later.
Okay, great. The build is a success. Let's go to pull requests and merge pull request. Confirm merge. And this will trigger the deployment.
2,000 years later.
Okay, great. Now let's go back to IntelliJ and synchronize our local main branch with the remote main branch. Great. In conclusion, finding items by search criteria enables users to quickly and efficiently find items or information that meet their specific needs and interests. By using a combination of specification and pageable, it allows for flexible and efficient querying of the database based on a varying set of search criteria and supports pagination out of the box. This approach is highly scalable and maintainable, making it suitable for applications that require complex search functionality. Now, Spring Data JPA specifications is another tool at your disposal to perform database queries. I hope you learned something in this video. See you in the next video.